Hello, welcome to Maths with AJD. I'm still talking about Fourier series. Of course, it's on its own as a playlist, but I'm adding it to the sequences and series playlist because it's Fourier series, right? And in this video, we're talking about spectral density and signal decomposition. Yeah, you have already seen how Fourier series is useful in signal processing, image processing, and things like that. Okay. So here we are focusing on power spectral density, having considered spectral density in the previous video. Okay, so um, in signal processing, signal decomposition, I can write that in capital for emphasis. Signal decomposition involves breaking a complex signal into its individual frequency components. And then we can begin to talk about PSD, the power spectral density, that is PSD for short, is a tool that quantifies, the strength of these components. All right. So then we can talk about the composition of a signal. We are talking about power spectral density and signal decomposition. So decomposition of a signal. So given a signal x of t, the decomposition process involves representing it as a sum of sinusoids. In the talk about sinusoidal functions, like functions that have crest and trough, so to speak, by representing it as a sum of sinusoids with different frequencies, with different frequencies. So the Fourier transform allows us to decompose the signal into its frequency components. So, and this is what that looks like. You have x of f equals integral from minus infinity to infinity, the signal x of t multiplied by e raised by minus I 2 pi ft dt. So we saw something like this when we talked about spectral analysis in the previous video. Okay, so the PSD, power spectral density, the PSD of x of t, which is the square, of the magnitude, of x of f tells us how the energy of the signal is distributed across the frequencies. Okay, now let's look at an example. So for a signal with a mix of low and high frequencies, the power spectral density might show dominant peaks at low frequencies, indicating that the signal contains more low frequency components. All right, so that's this idea about power spectral density and signal decomposition. Like I said, I have another playlist on scientific computing with Python. So there, I'm going to be talking about the fast Fourier transform. So there we are going to see how that relates with signal processing, image processing, and the rest of that. So you want to look out for that playlist containing fast Fourier transform. And if you have not subscribed to the channel already, you want to do that right away so that you don't miss out on the great content going on here. You know, you want to always be part of that. Hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are, and also let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. Then like and share so that more people can see these things. Bye.